What you can see here is the PIC microcontroller development board, and this board can accommodate the 16F877 PIC microcontroller. The PIC microcontroller is one of the most advanced microcontrollers that was introduced by the microchip. This controller is widely used for experimental and real-time industrial applications. Applications involve control applications, measurement purpose, and educational kits. The kit, the 16F877, features all the necessary device for the beginner to learn embedded systems. Compared to the previous versions of the PIC microcontroller, the 16F877 is a very good device for beginners who want to learn PIC microcontrollers. This image shown is the development board for PIC microcontrollers, and this board you can experiment the various peripheral interfaces like LCD, keyboard interface, LED interface, analog input interface, and many. The main advantage compared to the previous PIC controller ICs, the 16F877 is a high performance device, and further the programming of 16F877 is easier to learn for the reason that it has got only 35 single word instructions and single cycle instructions except the program branching instructions, which require 2 machine cycles. And the operating speed of the controller is up to 200 megahertz, and it has got 8K into 14 flash memory. The pin layout of 16F877 is also compatible with microcontrollers like 16C77 and 16C76. It has got 14 interrupt sources or interrupt capabilities, and different types of addressing modes are available with the 16F877 like direct addressing, indirect addressing, relative addressing, and there is a power up timer and oscillator startup timer inside the chip itself. The major peripherals of the 16F877 is the presence of 3 timers: timer 0, timer 1, timer 2, and the timers they will help you in creating time based events like LED blinking or controlled time based control of switches. And for all these sorts of experiments you need to have the timer programmed, and timer 0, as I told already, it can work in 8-bit mode. Timer 1 that is capable of working in 16-bit mode. And timer 2, again it is a 8-bit mode, and some more additional features are available. And the 16F877, it has got PWM facilities with 10-bit PWM output, and we have a multi-channel analog to digital converter. It is a 10-bit AD converter. You can supply analog inputs directly to the 16F877. The only thing is that the voltage, the any physical signal which is converted into analog signal, it should be in the range of 0 to 5 volts. So thereafterwards you can directly supply that voltage to the analog input. Actually, the 16F877, it has got 5 ports, and the ports named as A, B, C, D, E, they can work as input and output. And it also got a universal asynchronous receiver transmitter, UART, using which you can do serial communication with your PC or other devices working on serial communication mode. And the programming for the 16F877, that can be achieved by using in-system programming. Some other chips wherein the feature for in-system programming is not available, you need to remove the chip, and you have to use a separate programmer or IC burner to load the program. Whereas this chip is concerned, you can directly do the programming task without removing the IC from the circuitry board. The person interested in learning 16F877, that is the fundamental PIC controller, they can purchase this development board what is shown in this video. This board you can order from us, and we will also provide online tutor, online guidance for developing the programs, and that will help you to get a basic idea about how to work with PIC microcontrollers. And once you take up this training, I mean the online training using this 16F877 processor, thereafterwards you can update your knowledge with recent PIC controllers also. Any newcomer to embedded systems who is interested to learn PIC microcontroller, I would suggest them to purchase this controller board and take assistance from industrial people like us, and work on this processor to get a basic idea how to develop programs, how to verify the execution of the programs. So these things you can get exposed. Thereafter you can plan for advanced processors. To continue with the lecture what I was giving, the ports I told, no, port A, port B, port C, port D, and among almost all the ports are 8-bit wide. The port E alone, it is 3-bit wide. So all the ports are bidirectional. The direction of the port, it is controlled inside the program. When you write the program, you will use a specific instruction, TRIS, that will assign whether it is input or output. Generally TRIS is logical one to set a port as output. If you set it to if you set it to 1, it becomes a input port. If you set it to 0, it becomes a output port. This microcontroller, to make it work, you need to have a oscillatory circuit between pin number 13 and 14. The oscillatory circuit is connected, and it consists of a crystal oscillator and a capacitor. Probably you can utilize 22 PF for the capacitor. And ports are available in this board. Port A, port B, port C pins are available. You can make use of 4.7K array resistor, and to pull that way you can pull all the pins to high. Generally you need not leave the output pins floating, they are all open collector. So using a 4.7K resistor, the output pins can be pulled high. And basic experiments, you can start with programming the input outputs, and you can make some LEDs to blink, and that will help you to get an idea how to interface the IO pins. And you can also develop the knowledge about the usage of timer by developing programs for different LED blinking patterns. You can also achieve the full technical aspects or full knowledge about the technical aspects of timer. And any of the ports you can configure as input and output, and you need to have some compiler. Compilers like the MPLab or Micro C or PIC, any one compiler, whichever you find flexible for you, one compiler you can select. And there are many free compilers available as free source from embedded developers. So you can select one of these compilers and use them to write the coding and compile them.